Okay, very good. So this is the data type. The title is wrong, but we're going to cover today data types. As I promised you, since the last lecture, we're going to start seeing more like, programming concepts more than just like, compiler stuff, grammar and stuff. So hopefully it's going to be more fun for you, more interactive. For data types, so what do you mean by data types? This one is actually, you should be a bit more familiar with understanding, grasping the concept because of data structures. But first, this is my program. This is my program that I wrote. So what's going to take input? Let's say we feed it quiz grade, midterm grade, final grade. The output would be what? The final grade. Okay, so the total grade, correct? So technically, the program needs data to be able to produce results. Basic concept, we all know about this. If I have this, that's my input to my program, what's happening on a low level? From a low level perspective, what would be the program should be able to differentiate between? What should, like basic stuff, like we're just chit-chatting. I'm inputting this. What should the program be able to differentiate between? This is my input. What language is this? Yes, Zach.
Character, what's like a number?
Very good. So from a low level, it should be differentiated. 89 is what? Is a number. The other ones are strings, correct? So that's what we're going to actually go in detail. How is the programming languages dealing with these things, the types of things? So we're going to start with primitive data types, and then we're going to move to strings and then arrays and more complicated things. Most probably on Friday, we're going to continue. We're not going to be finishing everything today. But before we start, in data structures, especially the students that I taught data structure, what did we focus on? So we said data structure is the implementation of what? My students, don't embarrass me. So we said we always start with something and then we implement it to become a data structure. What do we start with? Exactly, like the ADT, which is the abstract data type. You see, now we're going to go in detail about the built-in data ADTs of the thing. If you remember in data structure, I told you we're going to focus more on, let's say, stacks, queues, and stuff, but we didn't even talk about, let's say, other things that they are already built in some languages. And one of the examples that I said, okay, that's how we implement a stack ADT. But then in Java, you can just call it. It's built for you. So here, we're going to see how different programming languages deal with these stuff. So what did we say about the ADT? So it's very similar. So I'm just going to connect the data structure with this. We said, how do we define a data type before implementing? So what is a data type? We need to know the data that we're going to put in it. What else? Do you remember? 3 things?
It's gonna do the function.
Exactly, the operations. Right? So we said what data, what type of data, and then the operations, and then we said, okay, errors and stuff. But the operations is very important. So actually, so these are some examples of primitive. I'm going to go through them, but a data type defines a collection of data objects and a set of predefined operations, which is very similar to what we talked about in data structure, right? About an ADT. So we cannot define an ADT without actually defining the operations of it. So very good. So therefore, a data type is not just a set of objects. We must consider all operations of these objects. A complete definition of a type must include a list of operations and the definitions. We're repeating ourselves here. Now, what about primitive data types? Now, again, data structure. What did we skip when we were doing time complexity? We used to skip something. Let's say, no, don't care about this, just focus on the loops. the loop will take off n or will take something. What are the other things that we used to skip and why we used to skip them? I want another. Zach.
Constant operation.
Constant operations. What did we call them? Primitive. If you remember, there's a slide, we explained it and we said, you know, these, we're going to always treat them as constant because these are the primitive stuff. And we said, these is like the addition, the assign, when you assign something. And why did we say these? We said, okay, these are primitive because they are more close to the memory and they don't, to the hardware, and they don't take lots of time from us. So we're not going to focus on them. We put them on the shelf, if you remember. So now we're going to talk a bit about these primitive data types. Some of these primitive data types are int, okay, for example, and other things, we're going to see it. So almost all programming languages provide a set of primitive data types. Primitive data objects are close to hardware, as we mentioned previously, and are represented directly or almost directly at the machine level. And that's why we don't need lots of processing for them and all of these things. So we're going to start. So some of these types are what? Are integer, character, Boolean. So we're going to talk about them a bit. So if I want to talk about integer, what's an integer? It's the most common numeric data type represented by a series of bits. Back then, in data structure, we didn't care about these things. Here, I'm going to show you a bit what's under the hood, and then we'll comparing it with different programming languages. For example, the difference between Java and C and stuff like that. If you can send me an email that you attended because you missed the attendance quiz, just send me an email now. So are there different sizes of integer? Now I'm assuming at least you took the Java course, which is the ITI 1121 or something. So you've covered these things. So what are the different sizes of integers? Yes.
64-bit.
Yeah, but like more like what do you call them in Java, for example? We have the int something. What else do we have? Sorry? It's called big, big integer or something. But other than that, the most common one, yeah.
Short and long?
Exactly. So the short, long, int and byte. So we have byte, short, int, long. These are the most common ones. And then we have the more like other things, which is the big integer and other things. Now, this is in Java. For example, other than that, when it comes to C++ and C#, we have something called signed and unsigned. So for the people who are studying C++, maybe you've seen this with the unsigned thing. Who's studying C++? Now, okay, what is the unsigned?
From 0 to like 4 billion, for example.
So what is the difference between unsigned and signed?
First bit is the sign bit. If it's 0, it's positive. If it's 1, it's negative.
That's the signed. The unsigned that means it's all positive. So that's the difference. Okay, very good. So if I have the signed, as we said, stored with the sign bit to indicate positive or negative value. So if I have something, I'm defining it as what? As byte. What is a byte? How many bits? 8 bits. That means each number I need to, because why we're even, hi Philippe, why we're even talking about these things, we always want to go down and understand what's happening on the more closer to the machine. If you remember, even when we studied the grammars and the compiler, we said, okay, why do we have even a compiler? Because we want to translate this programming language into what? Into a machine language, correct? Okay, so now the same thing here. I have this int, this byte. I need to translate it into something the machine will understand. So I'm going to end up with translating into bits. So if I take the first one, which is the byte, it's 8 bits. That means what? So first, this is the signed. We said positive, and it can be negative. The unsigned can only be what? Positive. Okay, so we're going to talk about them. Now, we're looking at Java, and we're taking an example as byte, which takes up 8 bits. What do we mean by that? That means I can store how many value 2 to the power of 8 values, which is 256. That's what byte means. That means I can have a value that is up to 256. I cannot have more than that. Okay, what if I need a bigger value? I want to store 1000 in it. I can't use byte. I have to use something else, which may be an int. The most common one is int. Why? Who knows? What does it represent? How many bits? 32. So 32. Why do we go 32, not 30? It's like 8, 16, 32, so 64, stuff like that. So that's the end. So now, guys, I want you to think about it from this way. If I want to link this to the signed and unsigned, we said signed will cover what? Minus, like negative and positive numbers. And I can only have 256. For the unsigned, it can only cover positive. So what does this mean? How can I translate it? Why I'm asking these basic questions, guys, because now here, you're going to link all of the stuff that we're learning for designing. Do you remember when we talked about grammars? We said these are the fundamentals or the concepts that anyone need to know to be able to come up with the language that you want, like designing them, understanding why we're using, for example, you may be hired in a company and it uses C#. Maybe the first question you're going to ask, why you're using C#, why we're not using Java, for example. But if you actually know the concepts, you're going, okay, they are using C# because of this, this, that. Maybe because the application that they are using, C# is better for it. And how are you going to find this? Based on the stuff that before even choosing the language or before even, like on the design level, why we did this. So from a design perspective, we said the unsigned are all positive, the signed negative and positive. That means if I want to represent them in memory, what's going to happen? And I can only have 256 value. So what are the value of my signed? So if I give you, if I have byte, byte num equal 200. Will work?
You only get 127 values.
Do you see? That's what I want you to pay attention. If you're using signed, that means you have to cover the negative and the positive. What does this mean? It means it has to go from 128 minus and then 127 for the positive numbers, because I can only have 256 value and I need to cover both negative and positive. But if I'm using unsigned, and that's why usually sometimes we use unsigned, is I can actually cover the 255 value. That means why it's useful to have unsigned sometimes if I don't care about negative. What it will give me? What?
Space or more
More space. It will give me more range. So I'll be able, for the unsigned, I'll be able to actually go till 255, for example, if I'm using a byte. Back then, these were very important, guys. Now we don't care about memory sometimes and all of these things. But back then, when they started looking at these things, that's why you will find, okay, unsigned is supported by C++ and stuff. Back then, they used to care about these things because of the memory and all of these things. Now, this is very important. So we said half of these numbers are going to be negative and then the rest. Now, if I'm using short, it's 16 bits. If I'm using int, is 32 bits. Now, when you're working in an actual company that they care about optimization, you're going to notice that sometimes in the code, you're going to find short. You're going to say, okay, why? Like, just put everything int. But no, maybe they care too much about the optimization. They want to save memory. They want to do something. So okay, I know that my input will never be more than 32,000. For example, I don't know why, but it will never be more than that. So I'm going to use a short here, because I don't want to book more memory space for no reason if I know 100% that I'm not going to use it. So these small details matters usually in the when we're designing something. Now, why it's 127, not 128 here? Raise your hand. Mateen. 0, of course. Because we have 0 plus 127, that's 128. Okay, very good. Now, the long, because we have here long, not all the programming languages usually uses long, okay? Some languages support integers with unlimited length, such as Python's long. So, for example, in Python, if you write this number, it will pass, okay? The good thing about Python, and that's why you're going to see me that I'm switching between Java, Python, C++, just to give you a better idea. The good thing about Python is that actually, if you write a number and you write it as whatever it is, it's going to automatically switch it to long for you, right? Why? What did we take in the last lecture? What is the type? And also it's dynamic, so it's not static. It will automatically switch this whole thing for you into a long number, for example. Of course, integer overflow will happen if you have something too large, even for Python. For int, if you're having an int for Python, it's too large, it will automatically convert it to long, for example. Now, in other languages, let's say like Java or whatever, no, if you're using an int, it's going to be an overflow. You cannot use this, change it. Now, we talked about the representation. So we're going to represent it with bits. But now, what about the storage notation? So how am I going to store them? So me think it's very straightforward. We have two ways actually to store them. Sign magnitude notation, which is very straightforward. That means I'm going to do what? Store the 0 or 1 as minus or plus bit. So let's say I have 8 bits. So I have 8 bits, for example, 2, 3, 4, 5, 6, 7, 8. So this one, I'll reserve it for the sign, and then the rest will be the number. Okay? But actually, this is not ideal for arithmetic operations on computers. We're not going to go into details because I'm sure maybe you've seen this in computer architecture or something. So what is the most widely used one? Not the sign magnitude notation. Did you cover this in other class? What do we do usually? No, we're going to go for the floating, but even for the integers. Actually, it's called two complement notation, which we're going to flip. We're going to flip the bits. So how? Let's see it. So if I have this as 5, so that's how the 5 in binary is. So if I'm using the two complement notation, I'm going to flip everything logically. That means it's going to be 1, 1, 1, 1, 1, 0, 1, 0. So I'm going to flip 5. I'll convert it logically, and then I'll add the what? The minus here. So this is going to be 1 on the rightmost. Do you see? And then this, we're not going to go into details, but this way, it's going to be much easier for you, for the computer to be able to do the addition and the subtraction and stuff. So this is actually also something good for you to know what's happening. Now the floating point, we're not going to go as much on details like the end, but you get the idea here. That's a float. It will have the sign here, 8 bits for the first, let's say 2 point something, and then this is the fraction. This is the double, 8 bits, 52 bits. So if I ask you, which one is more precise, the float or the double? Yes.
Can you go back to the previous slide?
Yeah.
And explain what you mean by add the minus?
So instead of having, so to add the minus, so look, where is it? Oh, it's here. So that's my first step, which is logical complement of the positive version. So I switch this, everything, like I flipped it. Now, if I want to add a minus, I'm not going to change this one. I'm going to change the rightmost. In this case here with the sign magnitude, we change usually the leftmost. So that's what we mean by flipping. That's why you notice here, instead of 0, I have 1 here, the rightmost. So which one is more precise if I want you to, if I'm asking you float or double, Felipe? Double. Why?
If there's more bits in the fraction.
As simple as that. So now, you know, if you're designing something and you want something to be as precise as possible, you're going to use the double. That's why if you want to call the, let's say the pi or whatever, If you're using double, it's going to give you more fraction if you're using the float. So these are important for you as a computer scientist to know these very small different things. Even though you can Google it actually, but it's good for you to know the design stuff. Now another one is also considered primitive is the complex. What do you mean by complex? Is the between the normal and imaginary number, right? So do you know any language that support imaginary numbers? What do you mean by imaginary number? When we have like, let's say 3 minus 5j or 5i, you know, like the imaginary numbers. Have you ever used it in any programming languages? Python, exactly. So Python, use it. Python also support the lambda calculus if we use it. So that's why actually Python is very popular. It's super, super flexible and they support lots of things, but this comes with what? With the downsides of many things. If you actually want something more controlled environment, Python is not good at all. But let's say you're using more like for scripting, more like for stuff, it actually supports a big range of things. So for example, in Python, if you write this 7 plus 3j, or like the capital J, that means this 3 as the imaginary part. So, okay. Now, how can we solve this in Java? Because I'm sure that maybe sometimes, somewhere, I don't know, in one of the assignment or whatever, you're using Java to do some mathematical stuff. How do we solve this issue? Because Java doesn't, for example, support this built-in wise. Yes.
We just started a couple.
No, other than that, like what do we usually do?
The class, right?
Okay, but like, is there something that you don't need to do it manually for Java? It's calling what? A library. That's why we have lots of libraries, because some of the languages, when they design them, it's not built in, so they will create libraries. So we're going to call the math library, for example. The math library will be something very simple like this, like one line, but actually the work is happening inside the thing. Or if you want to do it manually for something, as Samuel said, you can create your own class, but usually the famous stuff, the most popular things, it's already done for you using libraries, okay? Very good. So that's why I'm mentioning this. So you don't, let's say you want to build an application that uses this and then you want to do it Python just because of this. No. Other programming languages, they have lots of libraries. You can still use other.
I think you're the reason why we use J and not I.
I think, I'm not sure, but I think maybe I is used for something else. So it may be more confusing. So they go with J. Even though maybe Al will help me. When we took the power machine course, we used J, right? A lot instead of I. So it seems like J also is very popular actually in some different, maybe in engineering or something.
Especially MATLAB, I think it's C that.
Also J in MATLAB.
A lot of J use.
Okay, so that's why maybe, so it's a more standard thing. Now, if I move to the decimal, so what is a decimal? It's some things like similar to the float, but why can't we just use a float? Have you ever thought about it? Not all the languages, by the way, support decimal, right? What is the difference between decimal and float, Samuel?
Sure, but is it that this one is fixed point or is it something different?
It's very close. Primarily used in business application where precision with money calculation is essential because we want something that's so accurate. So that means if I use a decimal, I'll be able to be more accurate. We're going to see an example. So some of the languages that support decimal as a type are what are C# is. It's popular to support decimal. And also there's something called COBOL. I've never used it, but it's widely used in finance and business application and C#. So now here, there is another thing I want you to pay attention. So what are we linking? Again, think about from a data structure perspective, the concept that we talked about a lot that before, and that was not like this, it was more like building algorithms. What did we say? Before building my algorithm, I need to know what? Yeah, what did we call it? We had it P and A, right? We focused a lot on P and A. What is the P? The problem. So I need to find what is my problem. Let's say my problem is I want to enter people through the emergency room based on priority. That's why I'm going to choose the priority queue, for example, and then go to the implementation. So here, even here, from a design perspective, when they designed the COBOL, they had in mind, for example, that I want something that will be super, super easy when it comes to business applications. So I'm going to put some stuff that I don't need to call libraries. I know I don't need to do blah, blah, blah. I'll have everything, for example, built in for me if I'm using a business application. So this is something to keep in mind, guys. Always try to find what is the application that you want to do, right? What is the problem that we're trying to solve to be able, you're not going to design your own language, but to choose the best language for you to deal with, correct? Okay, very good. And that's why you're not going to study C, but C is super popular with what? With stuff more close to the hardware. If you work in a big company, like in my company that I used to, and the company that I used to work with, we had level 0, level 1, and then level 2, and then level 3, right? For programming. So I was like level 2. I used to use C++, but level 1, which was much more closer to the hardware, because we used to work with microprocessors, with more stuff like that. So they used to C. C is much stronger. It's much controllable for these type of things. So choosing the right language is very important for us. That's why we're not going to use Python to work with something like that, right? Okay, so we said decimals. So in storage, let's explain why it's different than a float. So we store a fixed number of decimal digits, then often uses something called binary coded decimal. So that means if you're transforming the decimal to a binary, so why the number 0.1 can be exactly represented in decimal type, but not in floating point. So we're going to see. So that's the decimal type. If I'm using BCD or something similar, we're going to use base 10. I'm sure that you took this maybe ITI 1100, like first year stuff, you saw all of these things. But decimal use base 10. If I'm using base 10, that means I have more bits, right? So I can be more accurate. This allows numbers like 0.1, 0.25, 1. So these are the fraction. We represent them precisely. So floating point type, if I'm using Java or whatever, and I'm using floats, which uses base 2, what's going to happen? It will be like this. So this 0, 1, I want to represent it, and I'm using the float, which is base 2, is going to have an infinitely repeating sequence like this. It's not going to end up actually with a precise number. So if I take this, if I'm printing this in Python, Java, or C, I'll end up with not 0.3, 0.300, and then 4 here. Now you're looking at this and you're telling me, okay, we were wasting our time. What's this? 0.0004. And what if you're working with stocks market? You know, this is called penny stocks. You know, these stocks that it's very like, oh, these things makes a big difference. You want something super precise, because let's say millions, billions of people are like entering the system, and these are accumulating at some point, ruining things. But if you're using actually base 10, now you're going to be able to have 0.3. So what is the conclusion of this? Decimal is much more precise. So it depends on your application. Now, so we know that the advantage for sure is that high accuracy for financial and monetary calculation. But what is the disadvantage of this? Sorry?
Redundant memory usage?
Of course. We're wasting memory if I don't need it. Let's say you don't really care. You're not working with any financial application or whatever. You don't need that much precision. So you're going to be wasting memory, right? So limited range, of course, and then memory intensive when you're using it. Very good. Now, Boolean. Boolean is very simple, right? It's invented, I'm not sure what year, by someone that I don't know his first name, but his last name is what? Boole. Okay. And then he's the one who invented Boolean algebra that you all love here. And okay, so of course it's 0 or 1, which represent true or false. So if I want to represent them, before. Okay, not supported by all programming languages, shockingly. It's example, of course, it's supported by Java, Python++, JavaScript, but even me, I didn't know that when I was researching this. It seems like the language C before C99 didn't support Boolean also, but then they, so the older language like C, for example, before C99 didn't support it. Perl seems like they don't support it also. So now, from a hardware implementation, because the same thing we did for AND, we know that it can be represented by what? But by 8 bits, 16 bits, or whatever. Now, I have 0 or 1. So how should I represent them? Bitwise or bytewise? Bit, Y, 0 or 1. Any other answer? Any other answer? Bit, are you sure? Isad.
Byte is made up of like 8 bits, or well, depending on the system.
So yeah, so your friends here are saying, okay, we're going to waste memory. So if I need only a bit, why do I need to book 8 for it?
For like memory addressing, right?
Because I want, let's say I want to represent true, which is 1. I want to reserve something in the memory for it, because everything that we're doing, even when we say the integer is 8-bit, 16-bit, that means what am I doing? I'm going to the memory, I'm reserving this 8-bit for it, right? Or the 16-bit or whatever. That's why it's waste of memory. Here, in this case, I have 2 options. Either use 1 bit, so that's the 0 or 1, or I'm going to use, for example, 1, 2, 3, 4, 5, 6, 7, 8, like 8 bits. Yes. Remind me with your name again.
Eric,
Eric.
use a byte because it'd be faster, and like a byte's pretty insignificant, so you can burn the 7 bits if you want. It doesn't really matter.
Beautiful. What is the keyword here? From what Eric said, what is the word that made music in your ear? Faster. Nowadays, back then, they used to do, for example, bit. We used to care a lot about the memory. Now, as Eric said, okay, 1 byte, 8 bits, who cares, right? It's not going to affect us. It's 1 byte. But if it's faster, that means I'm going to go with the byte, even if I'm losing 7. Why it's faster? Because modern computers, they all work with what? 8 bits, 16 bits, 32 bits. They all work with chunks. It's called word of data. That means it's much faster, because imagine the CPU or the computer is accessing the memory bit by bit. So it accesses here, then here, then here, then here, then here. It takes time from it. But if it's taking, let's say, bytes, like 8-bit, and then dealing with it by itself, it's faster, right? So that's why actually modern, as you can see, more memory alignment, generally faster than accessing individual bits. Most modern computers are designed to access data in units of 8 bits rather than individual bits. Accessing memory in larger chunk is usually faster. Yes.
Suppose we had some sort of class or whatever that had like 6 true false values in it. Would it make sense to put those in 1 byte together?
I don't know actually if you can do it with these programming languages, but I'll tell you something. When we program microcontrollers for small hardware projects, we use bits sometimes, not byte, because this very small microcontroller have a very, very limited memory, for example. So we want to actually use all of, let's say I have 8 bits, I'll say, okay, the first bit is for this, the second bit. So actually that's where we do it manually with the microcontroller. Yeah, but I'm not sure usually, and I don't think, because these programming languages are like built-in stuff, so you cannot change them. But yeah, if you're programming your own microcontroller, you can do that. So as we said, word size, the CPU often works with words of data. Very good, guys. What time is it? 11. Okay, very good. So we have time for the woo clap in a bit. Now, character. What is a character? Alphabets, right? So stored as numeric codings. Characters are typically stored as numeric codes that represent each character. Now, what are the common coding standards? ASCII, very good. You already took this. So ASCII is used to represent these, we're not going to go through details, of course, you already covered this. It's most widely used for representing English characters and symbols, uses 7 bits, often stored in 8 bits. We're not going to use only 7 bits. Why? Because we can just access the same idea, access 1 byte, even if we're losing 1 bit.
You now use the extra for the space symbol and the other like really.
And that's why you have 128 unique characters. So that means you have the alphabets plus the most common characters. We have more common, I think all the keyboard maybe that we have here. But what's going to happen? So A is represented as 65, for example, blah, blah, blah. Now, what's the problem with ASCII? It's limited to English and basic symbols. So anyone who doesn't know English or doesn't want to write in English, you cannot use a computer. True or false? False. So what can we use? Unicode. Unicode is actually what is other languages can be represented by. So developed to support characters from many languages and symbols beyond English. So the 16-bit Unicode, and there's the 32-bit Unicode. So this one can represent up to 65,000 something characters, originally used in Java for better international language support, and then it was actually supported by other modern languages. And then we have the 32-bit, which is humongous, over 1 million characters for some specific languages. So if I take an example, let's take Chinese character for water is this. Okay? So how is it actually represented? So the Unicode point, and then it'll be that the UTF is the UCS, just a different way of saying UCS. It's going to be like this, for example. Okay, so now ASCII versus Unicode. When is ASCII good? Best for English character, uses less memory. So that means if you know 100%, you're designing a language, an application, and you know 100% you're going to only use it with English. So why would you waste memory and use Unicode, correct? Then if you want to support multiple languages and symbols, then you're going to use the Unicode. So why use Unicode? To handle international text and special symbols effectively, especially in application that requires global. That's the key word here, guys, application. Again, depends. What is the purpose? What is the application? We want to think like computer scientists. Before using anything, why we're using this? Maybe it's better, maybe it's that, maybe there's an alternative. Now, we'll talk a bit about the string, and maybe we'll continue after. So now string is debatable. Why? Is it primitive or not primitive? Alp. It's not. Why?
Of characters string together in an array or some sort of other data structure.
Okay, so Alp is saying it's not primitive. Why? Because it is what? It's more than one character. Maybe we can put them in an array. Then if we have an array, array is not primitive. Okay. Any other answer? Felipe. It could be primitive. He supported his argument. Can you support your argument?
Well, depends on the language, you know.
Very good. Okay, so it depends on the language. Some other languages, they may treat the whole thing as one thing, for example. Okay. Other answers? Are we satisfied? It's both. It can be primitive or non-primitive, depend on the actual language. So the definition is a data type in which values consist of sequences of characters, as we said, and then the usage essential for practice requiring blah, blah, blah. Okay. Now, this thing that we're not arguing, we're discussing, is it primitive or non-primitive, is one of the design issues when it comes to strings. So when they were writing Java, then when they were writing C, that's one of the issues that, okay, should we do this primitive or shouldn't we do primitive? They are looking at the advantage or the disadvantage, and then they will be able to choose. So one of the actual design issues, if I ask you what are the two design issues for the string types, you're going to tell me first one is type classification, which is should string be treated as a special kind of character array or as a primitive data type? What is the other issue that we may think about? Similar to integer. What did we have? Have one kind of integer or we have multiple kinds? That's short, right, long, all of these kind of things. Yeah.
The amount of characters.
Yeah, the length. So there's another thing. What is the length of a string for me? So that's also another one. Should the length be static or dynamic? What do you mean by that? If you remember, we said static type, for example, forget about the length. The static type, it's fixed at creation, and then it's on the compile time, it's going good, and then what happened? And the runtime doesn't change. We said dynamic type like Python, it can change on runtime. So the same thing for the length. Some languages will actually allow dynamic length. Okay, we're going to see. So some of the common string operations are what? Assignment, concatenation. What do you mean by that? Actually, languages will allow you to add two strings, right? You concatenate. You have hello, you have world, add them to each other. Then a substring reference. What do we mean by this? Some languages will tell you, okay, you can go from the second character and take it. Comparison, pattern matching, and then, okay. So the first example is what Alps gave. In C, actually, it's used as array of characters. So char str is going to be this. That means I'm going to actually create an array and I'll put A, P, P, L, E, S of it, okay? Now, this is from the book. Bit of summary. C and C++ are not primitive. Snowball, primitive. Python, primitive. Java, it's a primitive like. So if I ask you, is Java primitive or not primitive, you're going to choose primitive. But if I give you three options, is it primitive, non-primitive, or primitive like, you're going to go with the primitive like. What do you mean by primitive like? Is actually Java creates a class called string that will deal with it, but you can call it as a primitive. Okay, so it acts like a primitive, but it's through a class called string. Then you have Java script, we're going to talk about in a bit. So if I take this example of C, in C, strings are treated as what? Arrays of characters, and then they have a fixed length. So strings are not primitive type in C, but rather are implemented as character arrays with a null at the end. Why do we have a null terminator? I think in C++ that's the same thing, if I'm not mistaken. Because one of the problems of C, and that's why it's dangerous sometimes to work with C if you don't understand the language. So there is a learning curve for C. And that's why if you learn C, sometimes you get ahead of other students when you want to get a job. Because let's say there is a job opening for Python, not just the computer science, even the biomedical, the mechanical will be applying for this for sure. Java, less competition. C, much, much less competition if you have it. But the jobs in C are not as popular. But actually learning C is strong. So let's think about this. Character, we're saving hello. This is a fixed size. So what happens in the memory, guys, here? We are booking, so this is my memory. What happens is here I have what? 1, 2, 3, 4, 5. So let's say that's 1, 2, 3, 4, 5. And then I have to put this here. Why am I putting this null terminator for the C? Because other language doesn't use the null terminator. I can just, let's say I have hello in Java, I'll just book like this. Hello, blah, blah, blah. Why we put the null terminator?
Mark where it ends.
Mark where it ends. Why? Because the problem with C, it's immutable. It's not immutable. So what happens is that if you change it by mistake, that's what I meant, you can actually erase memory because that's your memory here. And let's say this str that you created is 6, right? So 0, 1, 2, 3, 4, 5. So that's 6. You're storing in the memory 6. But if I want to modify this or concatenate it, I want to add something to it, what's going to happen? Actually, I'm going to add it here. So if you have something here in the memory, it will be erased. So that's actually one of the problems of C. You have to know what's happening. But in Java, it's not going to happen because Java by itself is immutable. That means I have this is fixed. If I want to add something or modify, what's going to happen? How can I solve this? But we're talking from a memory, so you're going to increase the size. But here, if you increase the size, you're going to destroy other memory, other variables that are stored next to you in the memory. Because remember, guys, the memory is like this room, this whole thing. You have to, a new string will be created for you automatically, and we'll copying this, putting it in the new bigger thing. What did we, if you remember from the data structures again, what did we use other than linked list? Because linked list will solve this, but if we want, we said extendable arrays. Do you remember the extendable arrays? He said it takes O of n. We proved the what. So we said this is done for you in Java. You don't have to worry about it. So if this is done, automatically it's going to be copied to something. Do you see now how we're linking things together? So that's what actually you do. While you go to fourth year, you get maybe more details in this. But so that's the difference here. So in this case, if I look here, so I'm creating this hello. It's fixed size. That's why it's fixed length. It's not dynamic. And then I'm printing this. Now, attempting to modify within the allocated space, what's going to happen for me? Let's say I want to change H. It's going to be able to change. Why am I able to change this? Because it's an array of characters. I'm able to access this index 0 and change it. So that's the strong aspect of this in C. I'm able to just manipulate this without creating something new. But if I want to concatenate something, I want to add word, hello world. What's going to happen? If I add the word here, it's unsafe. It might overwrite the memory. So if I take this, we go here. So Java. And then we go to the C. Because sometimes when I write online C1 doesn't show me the website. Okay, and so this is the one that I told you about. Let's run it. Do you see it passes? Say you hello, Jello world. It passes, but what did it give you here? Warning, built-in copy, writing 7 bytes into region, destination of the blah, blah, blah. It gives you a warning actually that you may be erasing things, even though it passes. So what does this show us? If you're using Java, it's much better. It will be built in, it will protect you from making mistakes. If you're using C, you need to be better. So we learned something, but not in C, we learned something to solve this problem. And if I'm not mistaken, in Python, when we worked with the array mutable, immutable, we said because the array or the tuples, if I remember right, in the ITI 1120, we said, I think the tuples or the arrays is that they are mutable. So how can I protect myself if I want to modify something?
So the tuples are immutable, arrays are mutable.
Mutable, exactly, the arrays. So we said we want to copy them first and then we change them just to protect the original one, if you remember. So this is also, you can do that actually in C, you copy them and then change it so you can leave the first one. There's lots of different things here. Now, I'm not going to continue this. We're going to see Java, Python, and there are other things. We're going to do it interactively with this on Friday, and we'll continue. So I'm going to do a book lab with you to cover what we took so far, and then I'll leave you in peace. So, what do you think? Is this more interesting than the grammar stuff? Or should we go back to parsing?
It was fun. Yeah, but
Actually, for the parsing, there is much more details. Usually, there is a compiler course. So actually, a full course on compiling, you'll learn all of these things in details. But because we're just covering the concept, the fundamentals, we took just a part of it in chapter 4, and we covered it. So let's do this. Can you just, yeah, behind you? Can you call him for me? You arrived late, right? Just send me an email now that you arrived so I can take your attendance. Philippe also. Okay, everyone is in. Which one of these are considered primitive data types? I didn't include string, so you don't tell me it's a trick.
Don't answer this if it's gonna come up, but is a bit technically a primitive type or a sub-primitive?
A bit? What do you mean? Because technically, the idea of a primitive is that the idea of primitive is that it's designed in a way in the programming languages that it can directly right away execute something, for example. Like you don't have to go through anything. So it's like, for example, int, it's represented right away as this. But for example, let's say an array, no, you can travel through it. So it's not primitive. So that's what we mean by primitive. So bit is part of, because everything here is represented by bit. Arrays are not primitive, guys. We said arrays, we can loop through them. It may be primitive. I don't know. On Friday, we're going to talk about arrays. Now, if I have a signed variable of type byte, signed, not unsigned, signed, what is the range of values it can cover? Think basic stuff, guys. Imagine you're a third year, fourth year computer science, you go to an interview and they ask you this silly question and you cannot use ChatGPT, you cannot Google it. So what should happen? Look, guys, ChatGPT, Google, I use it all the time, right, in my research. That's normal. But there is some basic stuff that we need to know, right? Why? Because in an interview and whatever, we need to know these things. It's 27, not 28, because we're going to include the 0. That's why it's 27, not 28. What is the benefit of using unsigned integers? So unsigned integer, what is the benefit? We covered it in class, of course. Positive values.
Can't you say that both are true because you could just use unsigned and just assume they're all negative?
Maybe, but like I'm talking about what we covered today in the class. I have to double check. I don't want to answer yes or no because I'm not sure. For the two complement notation, do you remember we said there is two different way to do the storage notation when it comes to the negative integers, if you remember. Which one is considered the two complement notation that it's mostly commonly used? Do we use the sign bit to indicate positive or negative? That means on the leftmost, we just put the sign bit, or is it the negative integer represented by taking the logical complement of the positive? Which one? Yes, it's the second one. Why? Because we said this one is going to make the computer, it will be easier on the computers to do the arithmetic work, adding and other things. So which one of these two types is considered to be more precise, float or double? Float or double? Float or double? Always remember this. Double has 52 bits on the fraction size. Float has only 23 bits. So double is more precise. That means it can cover more on the fraction size, okay? Wrong. Okay, let's go back here. So double. Now, decimal type uses what? It uses, let's say, the binary coded decimal to represent each decimal digit. Why is this not supported in all programming languages? There's no multiple answer here. I have wrong. why the BCD or the decimal is not supported, even though it's, you know, more precise using the decimal. Actually, both are correct. Why? Because BCD takes more memory. Why? Because it's base 10. Okay, so that's why it takes more memory, because it's base 10. So remember, guys, both are correct. Boolean 0 or 1 type is represented by bit or byte. So let's see if the soul of Mr. Boole will rest in peace or not. Is it bit or byte? 50. Guys, we spent lots of time. Eric will be mad now. He actually answered this. Now, if it doesn't show up next week, it's because of you guys. It's byte. Why? Bit, it makes more sense, but we said the computer, the CPU, access bytes faster. We don't to go bit by bit. CPUs, as we mentioned here, generally faster than accessing individual bits. We take words of data, which is like usually 8-bit, 16-bit, 32. It's just much more faster. Why is Boolean supported by byte? Because I answered this. I just entered. I forgot that I had this as a question. Because it is, of course, guys. We love to waste memory, of course. We love to waste time also and everything. So it's these two, of course. If you want to represent, that's the last question. If you want to represent international languages, which coding standards we should use, ASCII or Unicode? Of course, Unicode, ASCII can only cover the English language. Okay, guys, thank you. And I would recommend that you go to the career fair. Very important. Today from 11 till what time? At side building from STEM building from 11, side building, whatever building from 11 to 4 p.m.
Signal yesterday, and it's like, oh, so this registration.
Oh, you need to register?
I need you to.
Oh, okay.